All right, let's dive right into this explainer. We are going on a serious journey today, tracing humanity's epic expansion from our tiny blue marble all the way out into the mysterious interstellar void. You know, for millennia, we literally could only look up at the night sky and wonder. But, and this is wild to think about, in the span of just a single human lifetime, we've transformed from earthbound observers into a spacefaring species. We're actually sending robotic emissaries and ourselves out into the great dark unknown.
Think of this as our flight plan for today. We're going to cover leaving our home planet, footprints on the moon, our rocky inner neighbors, journey to the giants, and finally, the edge of the system.
So, starting off with part 1, leaving our home planet, the leap into orbit.
To really grasp this staggering scale of our solar system, we kind of have to start by looking at the razor-thin margins of those earliest leaps off Earth's surface. Getting out of Earth's gravity well requires an unbelievable amount of energy and engineering. And early on, we barely knew what the vacuum of space would even do to a human body. The intense pressure of the Cold War basically ignited a rapid-fire space race. It compressed centuries of scientific dreaming into just a dozen frantic years. I mean, we went from the world listening in awe and honestly a bit of a panic to the simple beeps of Sputnik in 1957 right to Yuri Gagarin orbiting our planet just 4 years later. And all of that culminated in humans actually walking on another celestial body by 1969. It's just incredible pacing.
But man, those first leaps were perilous. Take Soviet cosmonaut Alexei Leonov, for example. To survive his suit literally ballooning in the vacuum of space during the very first spacewalk, he had to make a terrifying split-second decision, one that easily could have killed him. He was floating outside his capsule, tethered by just 5 meters of fabric, and his suit expanded so much he couldn't fit back through the airlock. So what does he do? He had to bleed out half his life-saving oxygen just to get enough mobility to squeeze back inside. Talk about a stark reminder of how dangerous those first steps were.
Here's the big takeaway from that early era, though. Over time, those intense, fierce rivalries that launched us into space, they actually evolved into international cooperation. It turns out, leaving our planet brought us closer together. What started with repurposed ballistic missiles eventually became the Apollo-Soyuz guest project, where American and Soviet commanders literally shook hands in orbit. That foundation of trust directly paved the way for the International Space Station. It really goes to show that, in the extreme environment of space, we achieve way more as a united humanity than we ever could divided. Moving right along to part 2, footprints on the moon, our closest celestial neighbor.
You know, the moon has always been at that perfect distance, close enough to inspire us, but far enough to make us work incredibly hard for it. And getting there, it came down to the absolute wire. 16. That is the exact number of seconds of fuel Apollo 11 had remaining when Neil Armstrong and Buzz Aldrin finally touched down at Tranquility Base. Think about that. Computer alarms are blaring, they're heading straight for a dangerous boulder field, and Armstrong has to take over and manually pilot the lander. Mission Control was literally turning blue, holding their breath, and they landed on basically empty tanks. Absolutely wild.
But here's the thing. The true prize of reaching the moon might actually be what we saw when we looked back. By looking out at the moon's desolate, fractal surface, humanity looked back, kind of like into a mirror, and saw just how precious and fragile our own planet truly is. The Apollo 8 astronauts went all that way to explore the moon, but capturing the Earth rising over that barren horizon, that completely shifted human consciousness.
And since Apollo, robotic probes from all over the globe have uncovered some incredible lunar secrets. They've proven the moon isn't just a dead rock, it's a dynamic record of our own planet's violent origins. We've learned it most likely formed from a massive planetary collision with Earth about 4.5 billion years ago. We've even bounced lasers off retroreflectors left by the astronauts, which prove the moon is slowly drifting away from us. Oh, and the most exciting part? Modern orbiters have detected massive reserves of water ice hiding out in those permanently shadowed craters at the poles. Which brings up a massive question for our future. If we can actually mine this ice for rocket fuel and life support, the moon completely transforms. It goes from being just a destination to a vital refueling station for the rest of the solar system. Launching water from Earth is incredibly heavy and expensive. If we can just harvest it right there on the moon, well, that totally changes the math for how we travel to Mars and beyond.
All right, let's look at part 3, our rocky inner neighbors, the terrestrial planets. So, by exploring the extreme environments of our terrestrial siblings, we're actually getting a sneak peek into Earth's possible past and future. Mercury, Venus, Earth, and Mars, they all started forming from the exact same solar disk, right? Yet they ended up with wildly different fates. Just look at this contrast. Venus shows us the absolutely terrifying endpoint of a runaway greenhouse effect. You've got a thick carbon dioxide atmosphere trapping so much heat that the surface literally boils at 475 degrees Celsius, all under crushing pressure. Then on the flip side, you have Mars. It reveals this freeze-dried world that completely lost its ancient watery atmosphere to solar winds, leaving behind a barren, dusty desert. Understanding how these two worlds basically died is crucial for understanding how we keep Earth alive.
But hey, Mars isn't just a dead rock. Decades of work by robotic rovers like Spirit, Opportunity, and Curiosity have proven that ancient Mars was wet and warm. And now we're seeing these tantalizing hints of methane on Mars, which suggest those ancient dried-up riverbeds might have once hosted living organisms. See, methane is a biosignature. Here on Earth, it's heavily produced by life. Now sure, it could be geological, but it also means we might be right on the verge of finding out we aren't alone in the universe. How cool is that?
And if we wind the clock back, Mercury's bizarrely massive core tells a really violent story about the solar system's early days. Just look at those numbers. Mercury is 85% core by mass. Because it sits so incredibly deep in the sun's gravitational well, the intense radiation and solar winds of our infant star literally blasted away the planet's outer layers. It basically just left the heaviest elements behind. It's a cosmic survivor.
Okay, moving out further. Part 4, Journey to the Giants, Crossing the Asteroid Belt.
Venturing past those rocky inner worlds, our robotic probes had to survive crossing the asteroid belt just to reach the massive gas and ice giants that govern the outer system. For a long time, scientists thought the asteroid belt would be this impassable field of crashing rocks, but Pioneer 10 proved it could be navigated, completely opening the door to the outer solar system. And when probes like Voyager and Juno finally got to Jupiter, they found a true monster. The sheer scale of Jupiter is a striking reminder of just how small we are. It acts like a massive gravitational bully, actually shielding Earth from catastrophic impacts by vacuuming up stray comets and asteroids. And its defining feature, the Great Red Spot. It's a hurricane so vast that multiple Earths could fit inside it, though, interestingly enough, it has mysteriously been shrinking over the last century.
But you know, scientists are incredibly excited about the outer system, not just because of the giant planets themselves, but because of their moons. Worlds like Europa and Enceladus possess subsurface liquid oceans, strong energy sources from gravitational friction, and complex organic chemistry. Meanwhile, you've got Saturn's moon Titan, rocking a thick atmosphere and literal liquid methane lakes. These moons have completely shifted our paradigm. They are, without a doubt, our absolute best candidates for finding extraterrestrial life today.
Negative 224 degrees Celsius. Let that sink in. That is the lowest recorded temperature anywhere in our solar system. We found that in the atmosphere of Uranus, which is this bizarre ice giant that got knocked entirely onto its side by some ancient collision. Because it spins on its side, its atmosphere goes through these incredibly extreme, freezing conditions. We've only ever visited Uranus and Neptune once, just a brief flyby by Voyager 2, which leaves them as some of the most mysterious worlds in our entire neighborhood.
Finally, let's venture to Part 5, the edge of the system, into the interstellar void.
Out here, the light of our sun fades into a mysterious twilight realm of small icy remnants. We're talking about the absolute outer limits, billions of kilometers away. Communication takes hours, and the sun? It's really just another bright star in a black sky. When the New Horizons probe finally reached this region, it totally shattered our expectations of the Kuiper Belt. It showed us that even at the dark, freezing edge of the system, worlds like Pluto are actually vibrant, active, and full of surprises. I mean, we're talking 3-kilometer-high mountains made of solid water ice and flowing glaciers of nitrogen. Plus, the strange, stretched-out orbits of rocks out there strongly suggest there might be a massive, unseen Planet 9, like a super-Earth, just hiding undetected in the dark.
1.4 billion. That is the distance in kilometers from which the Cassini spacecraft looked back through Saturn's rings and photographed the Earth. From that far away, our entire world, every human being you've ever known, every ocean, every mountain, was reduced to a single, tiny, pale blue pixel of light suspended in a sunbeam. Honestly, it's a profoundly humbling perspective.
And as the twin Voyager probes crossed the heliosphere, that's the boundary of our sun's influence, and officially entered interstellar space, they carried this poetic message with them. It represents the absolute best of our human curiosity. Placed on a golden record designed by Carl Sagan, it features music, images, and greetings in different languages. It's nominally a message for extraterrestrials, sure, but really, it's a message to ourselves. It's proof that we have something special on this planet that is worth sharing with the universe.
So I want to leave you with this thought today. This entire journey proves that pushing the boundaries of the unknown is actually the ultimate way to understand the home we left behind. We didn't just go to space to plant flags, right? We went to figure out how planets live, how they die, and how we fit into this massive, incredible cosmic puzzle. So the next time you look up at the stars at night, ask yourself, what will the next generation of explorers find when they push those boundaries even further? Thanks so much for exploring with